Okay. Also, I love this because it's insanely accurate whenever you're like really big on something that's just pure science based. Like, I don't care about titles. I don't care about my last name. I'm just Ben. I give you this. It'll do. Also, it really bothered me that they misspelled it flags. Okay. So we're just gonna start off playing around with inequalities. Last time I taught this class, I started this off quite early, and apparently that was a mistake and people freaked out. And then there were less people in the next class. So, you know, that was fun. So I brought it over to be in line, well, next to lines. So we're used to playing around with equations. We've done a lot of the word problems with equations, but the word equation literally means you're equating two things. One thing is equal to another thing. Inequalities have different symbols, and they're literally just saying, well, the sides aren't equal in this case. They're tilting one way or another way, or they leave you an option of having it equal to the other side. So we have a couple of symbols. I'll just jump over to the chart I have. A couple of symbols. We have greater than and less than symbols. So starting off, there's a less than symbol, and literally it just means the thing on the left is less than the thing on the right. It's always kind of opening up towards the larger thing, and it's always red left to right. So that might make the whole which one's greater than, which one's less than easier. So if you see that symbol, it's saying the guy on the left is smaller than the guy on the right. The other way around, the next line there, you have a greater than symbol. So it's saying the thing on the left is greater than the thing on the right. Then you get a couple of weird ones. They're literally the exact same symbols, but they have a bar underneath. And it's basically a combination of those two inequality signs and an equal sign. Having that bar underneath is the one where you have the option of it being equal to that. So 4 is less than or equal to 4 does end up being true, but 4 being less than 4 is not true because 4 is not less than 4. It has to be smaller. So the or equal to gives you the option of going up to that endpoint. And that's particularly useful for different levels of graphing and being able to show things on number lines. And then we'll have interval notation here in a second, and that's a big distinction between the two. Do we like it? Guys like it? Happy with it? Everybody happy? Okay, real. All right, cool. Good talk. Well, here we got some comparison stuff. Also, the meme is very, very accurate. That on Taylor Swift, that's when people are having fun. I'm the same way when Taco Bell releases a new specialty menu. So I get it. Taco Bell, Taylor Swift, about the same level. Personally, for me, Taco Bell's higher. Okay. So out of these, which one's bigger? The left one?
Right.
That one?
Yeah.
Okay, we got to vote for both. Either of you want a tiebreaker? Feel the pressure? No? Okay, we're dead inside today? Me too. All right. So the main thing is you want to look at the place values. So 2.3, that's the same. The next digit is 9. Next digit over here is an 8. What's bigger, 9 or 8? Okay, cool.
Never mind.
It's okay. I'm not judging you too harshly out loud. So is it going to be a greater than or is it going to be a less than? It is going to be a greater than because it's always left to right. So left is greater than right. Next one, 529.42 versus 530.41. That is true. I am disappointed because I always put that in there hoping that somebody looks at the 2 versus the 1.
So catching up, always.
I had one class that got all of them wrong, and I was strangely happy about that because I made them all to be trick questions. So, but yes, it is going to be the 530.41. That one is larger because we don't care about these digits. The larger ones, the tens place is a 2 here and it's a 3 over here, so it's larger there. And since that one, the left side is smaller than the right side, we will use a less than, right? Yes. 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 All right. All right. Good. 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 Okay, number 3. I'm not even going to read it out loud. What do you think?
Right.
Okay, we got a vote for each.
I don't know. I'm gonna say left one.
Okay, now shading your answers here. All right. You picked both. You don't count. All right, so. All right, that works. So it is going to be the right one in this case. The main thing there is how many zeros there are. It's all about the place value. Here, the hundreds place is a 0. Here, the hundreds place is a 6. 6 is bigger. So, right side is larger. If the left is smaller than the right, the left is less than the right. Yeah? Less than? Little arrow thingy, kind of pointing at the sad one. Kind of works. Ish. Well, have a little bit of a lesson on interval notation, then we'll go back to inequalities and actually, play with them. So we get this beautiful thing here called interval notation. So the thing is, when you have to describe anything as an answer to an inequality, if you get something where you have this is less than 4, well, what's less than 4? 3, 2, 0, etc. You don't get one answer, you get a range of answers. So how do you write the range of answers? You actually have a couple of different ways. You have this option right here, which is called set builder notation. So if you have a set of values of x such that -3 is less than or equal to x is less than or equal to 1, we can write that in a way that's less confusing, which is great because I'm not huge on set builder notation. So this might look confusing, but I would much prefer this guy right here. So the basic idea here is we'll have an example of a closed interval. So this is saying we have a range between one number and another number. And on this particular example, both sides of that range are included. So this one goes up to that -3 and includes it, up to that 1 and includes that. So that's considered a closed interval because neither side is open. Neither side is, open circle, not included. So what you do for a closed interval is anytime you have a point where it's or equal to, so it's including that value, you will use a bracket. So interval notation is written in this way. You always have whatever your symbol is to start your interval, the left endpoint, comma, the right endpoint, and then whatever symbol we need. So here we have a closed interval, which means our symbols are going to be just brackets. The brackets basically are saying, hey, it's included on both sides. It's always left or right. So on the left, we have a -3. On the right, we have a 1. So it's just the range of numbers between -3 and 1, including both ends. That's how you read that. And in my opinion, I would much rather look at this than look at this thing. Now, that's all well and good, but this guy in the middle actually does make sense, right? Because if you look at this, you're basically saying, okay, X is between -3 and 1. So you could look at it that way as well. But we're not going to have anything with an answer that looks like that. Okay. Now, that's a closed interval. We also have open intervals. And the only difference there is it's not including the endpoints. And in that case, you just use parentheses. If you don't have a less than or equal to or greater than or equal to, you just have less than or greater than. All you do is leave an open circle on your number line, or when it comes to the interval notation part, you will use parentheses. I always kind of looked at the parentheses as it's going up to that point, but not quite including it. So the bracket is including, the parentheses is not including. And it's the same interval, right? -3 to 1. So you see this less than, that's telling us, okay, it can't equal those endpoints. So you put an open circle here, parentheses here. Alternatively, if you're putting these things on the number line, one thing I used to do when I was in class is I would put the brackets or parentheses directly on the number line. I would write this out as parentheses across that -3, parentheses across that 1. Oh, we're rocking the volume again. You can literally feel it through the floor. Okay, cool. That derailed all of my thought processes. Problem with ADHD is you got like 5 thoughts going on at any given time. Something throws a wrench in that, they're all derailed, all of them. So ignoring the bottom of this screen, the top example is pretty much just a decent application of this. You can have intervals that are half open and half closed. That literally just means one side's included, one side's not. So if I was to just look at my number line here, ignoring the fact that I actually clearly have the answer right there, I would look at this and say, okay, well, cool. My classroom used to be loud. We would hear it through the wall from here. I wish they would just put a class between them. So if you're making this thing interval notation, you take a look at the left endpoint, -2. You say, okay, is it including? Yes, it's a filled in circle. So you'd say, okay, -2 is going to have a bracket around it because it's included. And then you say, okay, well, where does it end? So you got the bracket, -2, comma, you go to the right endpoint, we'll go over here and we're at 4. Okay, cool, we're at the 4. Then you say, okay, is it open or closed? It's open. So we would use the parentheses to close it. So you end up with bracket, -2, comma, 4, parentheses. So you literally just have, what's the left one, what's the right one, and is it included or not? If it's included, bracket. If it's not included, parentheses. So once you get that down, it's incredibly easy. Now, I did find this particular example on the internet. It is incredibly unlikely you will ever see anything like this. This is hideous. I have multiple times had to Google how I would put a single dot on interval notation. I opted for the option of the set of numbers being that one. Another option apparently would have been bracketing and saying my interval is just 4 to 4. Apparently that's an option. But if you have to ever deal with something that has multiple intervals like this, first of all, do each one separate. Don't look at the whole thing at once. See this whole thing over here and freak out. I don't care. Do it a little bit at a time. See that one? You're like, okay, I'm going from -4 to -2. Brackets on both because it's including on both. Okay, now this guy, since there's a hole in it, this is actually 2 intervals. So it's from here to here, -1 to 1. So you're like, okay, well, yeah, okay, -1 to 1. And we got open circles on both sides, so parentheses on both sides. Okay, then we got this little guy, 1 to 2. Not including on the left, including on the right, parentheses, bracket. Okay, then we got a 4. How the hell are you gonna put a 4 in an interval notation? It's not gonna come up. It's just not, but this is one way, is put little squigglies saying it's a set of numbers and just slap a 4 in. It's an option. But see, what I did is we have each of those intervals separately, but then we got this little U thing hanging out in the middle. That symbol means union, and it's basically saying, okay, my answer is this as well as this. So as long as you have more than one interval, just slap that U thing in the middle and you're good. Questions, comments, concerns, screams?
So my question is, so for your -1 to 1, and that's one set, if you will. What would keep you from going, well, what about -1 to 2?
So the problem there, -1 to 2, while it looks like it's one interval, you have a hole. And
Okay.
because there's a hole that breaks it, it has to be 2 intervals at that point. So even though it's only an instantaneous hole, like literally, okay, we're at 1. Well, what about 0.9999999999999? Yeah, technically that's in here. Everything up to that one. Slap a bunch of 9s in there. Yeah, it'll round off to 1 eventually, but who cares? Only at that instantaneous point is there a hole. Now again, are you going to ever do something as hideous as that? Probably not. But if you understand it, then you got it down. That's pretty much my goal, right? So let's play with some of these. Oh, I love this. The ultimate level of reincarnation for me would be coming back as a goat that gets to knock down children at a petting zoo and suffering no repercussions for it. That would work. That would work. Things, people being ridiculous on the internet and then going to work and asking all my coworkers if they would still love me if I was at work. The proper answer, if anyone ever asks you if you would love them, still love them if they were a worm, proper answer is I would love you more if you were. It's kind of brutal. So we got some inequality equations. Inequations? Inequality agents. I think it's described Taiwan accidentally. I'm gonna call it an equation because I have no better word, but I think technically that makes these inequations, which is painful for me to think about, and I don't think I've ever. That'll do. Okay, so we got 3x is less than 9 plus 3. Now, for the most part, when you have an inequality, you're gonna just solve it like you normally would if that was an equal sum. There's only very select situations where you wouldn't. Now, as it is right now, all I'm gonna do is just solve this as if there's an equal sum. I can immediately add the 9 and 3. We'll get a 12. We have 3x is less than 12. Divide both sides by 3. Get that x alone. We get x is less than 12 divided by 3 is 4. X is less than 4. But we just learned about interval notation, so we should probably play around with interval notation just so we get used to it. Isn't that great? No? Okay, well, deal with it. All right. So, you guys are gonna love my number lines. My number lines are really incredibly detailed and impressive. There, that's all I care about. That's a number line. I'm happy with it. That's the only number that matters to us, right? We're not listing different points along that number line. So that's the only frame of reference I really need. So what is this telling me? Well, it's saying x is less than 4, right? If x is less than 4, is it going this way or is it going that way? It's less than that, right? You always go negative to positive. So it's going to be going this way. So we just kind of send that off forever. Literally forever, everything. You know, what x's are included? All of them that are less than 4. Well, what about negative 50 billion? Yes, that is included. So, question is, speaking of inclusion, is the 4 included or not? We have a less than symbol. So are we going to use an open circle or a closed circle? Or are we too dead inside? All right, that seems likely. That seems like the answer there. All right, so we have a less than symbol, which means it cannot equal 4. It can only be less than 4. And because of that, you will use an open circle right here. Do that make sense? Do that make half sense? Do that make quarter sense? Okay, guys, I would also like people watching Netflix, but here we are. Embrace the math. Give me but another hour and a half of your life, and then you will be free. Okay. And then my last class, potentially ever, I don't know, potentially ever, will be Thursday. Huh? I'm leaving it open for interpretation. Somebody needs, I'm literally only teaching this class because the person who was teaching this class before me could no longer do so, and something had come up, and I was just like, all right, yeah, I guess so. And then I just jumped into it in like the week 2 or 3 and took over. And then I just did it for 3 years. Because, you know, sometimes you just accidentally do something for 3 years, you know? I worked retail for 13. It was horrible. I do have indispensable life skills, though. The guy who had my current position at work quit because of stress. But since I worked retail management and took over the lab, hello? Getting for you. It's cool. But yeah, I took over the lab and I'm like, yeah, this is nothing. You guys are cute. You don't know what responsibility is. My God. Friends don't let friends work at GameStop. Retail PTSD is real. Okay, So we get to play around with interval notation. And I know you guys already love interval notation. You all lit up when I switched over to that slide. Eager and happy, weird little noises like, No? Okay, that's fair. So interval notation is always written left to right. Always, no exceptions. So the question is, what's happening all the way on the left? We haven't run into that, right? So far our intervals have all been, from this point to this point, this point to this point. Or that weird one where it was just this point. What do I do if it keeps going on forever?
Hello? Housekeeping?
Did that for a while too. Oh, hi, I missed you. Welcome to the party. Always, this party is very happening. Okay, so again, we haven't played around with an interval going off forever. So what can we use to represent forever? Well, the fun thing about number lines is that at all times, the number line is going on forever in either direction, right? We're always just technically looking at a little part of it. Yeah, I could slap a 3 on here, I could slap a 5 on here, 6, 2, whatever. But I'm always just looking at a little snippet of it. But it does go on forever. So the implication is that when it goes on forever in this direction, it is going towards negative infinity. We are giving that a designation. We're giving it a name that we can actually be like, oh yeah, if I gotta say something goes on forever, that's what I'm gonna use. Now, we also have positive infinity. Now, you might say, hey, both of those kind of represent the same thing, right? Forever. But the main thing with the negative and the positive is direction. This negative here is telling us, oh, it's going forever towards the negative direction from this point. This positive infinity would be going forever in that direction. So when it comes time to actually write this out in interval notation, and we have to start from our left endpoint, we don't have an endpoint, right? It goes on forever. But if it goes on forever to the left, we start with a negative infinity. Now the question is, do we include negative infinity or not include negative infinity? What's happening at that endpoint? Not really an endpoint, right? Keeps going. Goes on forever and ever. Like when you wake up in the middle of the night, you can't sleep. Forever. You ever notice the time seems to be like 5 times as long when that happens? What the heck? That's not cool. If you get up and you're like, you know what, I'm gonna pay attention to an episode of Bob's Burgers. Nope, you're just gonna pass out. Yep, that's right. Well, we can't include the last number in infinity, right? Because there is no last number in infinity. It keeps going. So you always use a parentheses when you're playing around with infinities. You always just slap a parentheses on it because you can't include the last number in infinity. So we're technically starting from negative infinity, and then we're going up to 4. Right? What's happening at 4? Wasn't included, right? We have an open circle. And if it's not included, parentheses. So if you look at your interval notation, it's really just a direct translation of the number line. It is literally just, hey, this is going on forever to the left, up to 4, not including it. Direct translation of a number line. So a lot of times, I'll just make a number line if something's confusing looking, and then I will just go straight below it to make an interval notation. Like, okay, well, that happened. What do you guys think? That's the easiest problem. Are you excited? Did I make it hard? Okay. Lively bunch. All right. This one is gonna end up almost the same thing. We have 2y is less than -8. Now, problem-wise, not much of a problem, right? Because I can just divide that 2 on both sides, and I'm good. Divide off the 2, divide off the 2, and we have y is less than a -4. Does anything weird happen with this one being negative versus the last one? Does anything weird happen with it being a y as opposed to the x in the last one? No. Our variable is just, hey, this is your answer. Your answer is less than 4. Your answer is less than -4. It's just a stand-in for whatever I don't know. What do we not know? I don't know, but it's less than -4. So let's do a number line. And we got the same direction. The only difference is instead of a 4, we got a -4, right? And it's still going to be less than that. So we're still going to go off in this direction. And since it's a less than, it's still going to be an open circle. Okay, not the end of the world. How do we do the interval notation? Well, left to right. On the left, it's going on forever. So it's -infinity. On the right, it's just going up to that -4. And then do I include either side? Well, in infinity, you never do. You're gonna have a parentheses. And for this open circle right here, we are still gonna have a parentheses. So it's almost the same answer. Feel free to prop the door on your way out. Oh, you literally just push it against the wall. Oh, oh, I believe in you. Oh my God, you did it. That's magic. That was great. Watch, their speaker's gonna start up again here now. Oh my God, door's open. Yeah, it's just put it as is. Just thinking about changing it and making it more awkward, but. One thing I like to be more awkward. Oh my God, I hate it when I'm just teaching and half my class just walks out all at once. Oh my God. This class starts usually with a fair amount of people and then it dwindles. The people who were here day one, a lot of times I'll like to look around the room and take a guess about which ones were still gonna be here by the end. I was wrong. Sometimes I'm right. I figured you would be. He did first, and then, she was here the other day and said, you know what, I gotta go, and she ran out and I never saw her again. Okay, okay. Okay. So we got 12 is greater than or equal to x plus 5. That's also an easy one to solve, right? You just gotta get the excellent. Subtract the 5 off. If 7 is greater than or equal to X. They did it, you see. They knew the goal. Conspiracy, man. Yeah, so if 7 is greater than or equal to X. Oh my God, guess what my number line looks like? Oh my God, the effort. Oh my God, the effort. When I was taking classes, I would actually like, all my number lines would have at least like 10 little marks and it'd be like all perfect. Well, it looked like garbage, but you know, to me it was perfect. Because my handwriting has gotten better since then, believe it or not. And you know, now I just like, I literally just put the necessary information. That's it. I don't need more information than that. It's a 7. What do I know? 7 is greater than or equal to X. Ah. Does that mean it's going to go to the left or does that mean it's going to go to the right? Well, it was. Hmm? Mhm. You've already seen this one at one point, so I don't, you know. Cheating. All right, so here's the thing. 7 is greater than or equal to X. You would see the greater than and you might think, okay, bigger, so right, going to the right. But the problem here is that all of these were X is less than, Y is less than. 7 is greater than, that literally just means that 7 is larger than all of my correct answers. So if 7 is larger than that, it'd have to be going the other direction. Now, this has always been a kind of an ugly thing for me to wrap my head around. Not a big fan of that. Something doesn't compute, I don't like it. So what I like to do is when I solve an inequality and I end up with my variable on the right, I always take that whole thing and flip it around. And taking care to also flip around the symbol. So 7 is greater than or equal to X is kind of confusing to wrap your head around. X is less than or equal to 7, that I can get behind. That makes more sense, right? So, well, I think at one point I had actually changed this to be facing the other direction. And then I looked at this, forgot what my setup was and changed it back because I realized that all of my answers were going to the left. And you know what? It's less than or equal to 7. Guess which direction it's going? Oh my God. I'm getting used to that. Oops. Oh well. Now, we have a less than or equal to. We have that bar down there. That's our first bar down there. Yay, we like it. These ones didn't have the bar, so they weren't including that point. We used an open circle. This one does have that bar, means it could equal that 7. So we use a closed circle. Isn't it beautiful? Okay. What does my interval notation look like? What's happening on the left? Same thing that happened twice already, right? It's going on forever to the left. Gonna have a negative infinity. What's happening on the right? Goes up to 7. We're gonna have it go up to 7. Probably should have given myself a little space between those, but whatever, you know. We're just gonna make this 7 smaller. Look at that. Oh my God. Beautiful. Still a 7. All right, but what's happening then? It's including. Both of these previous problems weren't including that one. This one is, we have a closed spot here, so we're going to use a bracket. Okay,
Yeah, look, he's in the car.
oh. How did you get into the car?
Oh,
Is it unlocked? What do you drive?
Honda.
Yeah?
I don't lock that. I don't lock that thing.
Oh, okay.
He's like.
All right, grab me something. Ah, that's fair. I always made my brother and my dad always watch car shows and they're always freaking out about classic cars and I make them angry because they're like, yeah, if they ever ask me, hey, what kind of car do you want? I want a really generic looking beat up silver four-door Honda. Why? Urban camouflage. They're everywhere. I can't tell the difference.
That's why I like mediums.
Mhm. I would take that and I would find a fake business, make some fake business magnets, slap them on the side. I would basically be invisible to police. Company vehicles tend to get pulled over less. Generic looking cars tend to get pulled over less. So, you know, urban camouflage.
All right.
Yeah. Gonna tint the windows? No, because that'll make people pay attention. One more hanging out in interval notation. We excited? All right, I'll take that as yes. We have negative y is less than or equal to 2 plus 3 because I just kind of made it a problem. As you can tell, these problems have been quite easy. I'm not trying to make that part difficult. I'm trying to wrap your head around interval notation and inequality. Now, I know you guys have been quiet. Do we know what 2 plus 3 is? 7? Okay. I don't really put out grades, but you just failed. I'm sorry. You know. Parents are very lovely people, but I'm disappointed in both of them. You got 2 plus 3? 3. Yeah, 3? 4? Wait, that's a thumb. Does that count? Yeah, I guess it'll count. That's 4? 5. Okay, that was 2 more, right? Yeah, because these are 2. This is 3. That makes 5.
Yep. Yeah, no, they're coming up.
Hold on. Make sure. Okay, if I change this between a decimal and a fraction, it seems to stay 5. So, yeah, I think we're good. All right. Seems to be 5. Okay. Negative y is less than or equal to 5. Do I want a negative y as my answer? No. So we gotta divide off the negative, right? Now here's the fun thing. This whole thing we have been playing around with. All of these symbols have basically been the same as an equal sign. The only exception so far has been this one where I flipped it around to make better sense of it. But here's the thing. If I have a less than symbol, so one side is smaller than the other, and that side is negative. And now I'm suddenly going to take that negative, flip it around, and the other side is going to get that negative. I just took that scale and I flipped it completely, right? It just went wonky. So what happens when I divide both sides by a negative, the numbers are going to do exactly what you expect them to do. I'll have a positive y and a negative 5, but the symbol has to flip around. has to go the other direction because what was negative is now positive and vice versa. Do it compute. And that goes for if you divide or multiply by a negative number. Going back to number 2, we divided a negative number, but we didn't actually change the sign on either side. So it only matters if you're changing the signs on either side. Okay? Something, something number line. We've got a -5. Look at it. It's beautiful. Wait, let's make sure we're right. 5 divided by -1. All right, we good. All right. Okay, so -5. And this one is greater than or equal to. Oh my God, I have one that actually is going the other direction. It is larger, so it's going that way. Haha. Excitement. We're excited. That was somewhere below excitement. I don't know what that was. It made me uncomfortable. All right. So this one could equal, right? We got greater than or equal, so we will use that wonderful closed circle there. Then for our interval notation, always left to right. We're going to start at the -5. We're going to go on, well, it goes on forever in the other direction this time. Finally got to a positive infinity. On that -5, it's including it. If it's including, we use a bracket. If we aren't including or we have an infinity, use a parenthesis. -5 to infinity. Do you like interval notation? That's something. I'll take it.
Kind of comfort.
Yeah, I lay awake at night sometimes and think about it.
Just do interval.
Yeah, just, you know, it relaxes me. The sheep I count approach infinity.
Watch that.
I mean, I did just say the limit approaches infinity and you haven't even looked at limits.
Replacing the main approaches.
No, limit. You want to see something horrifying? First chapter of calculus. Oh my God, no, I'm not going to give you money, Con. All right. So the idea of a limit is that if you have a graph with, say a hole is there. If there's a hole right there, then you don't have a value there. But since the graph is approaching what would be there from both sides, the limit there is 5. So you can get values that are approaching, well, you can get answers that are approaching a specific value, whether it's actually there or not, which makes things a little funnier when you play with infinite limits, and then you end up with, what a graph. This isn't useful. Give me something, yeah, there we go. Perfect. Oh my God, not perfect. Where is it? Perfect. All right. What? Hi, I started doing calculus. Welcome back. It would make sense if I was joking, but I'm not. Yeah. The limit at A, So you're just saying, oh yeah, there's some point A. What's happening? Graph's going up forever. Okay, what's the limit? Well, same as a number line. It keeps going up forever. It gets really, 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 really close to that A, but it doesn't stop going up. It's infinity. So there's that concept of infinity coming from a number line going to calculus. Isn't that beautiful? Also, this is vector graphics. This isn't just a picture, so I could like, no, won't let me go higher. I could zoom in forever, technically. Bye. All right, so luckily we're not doing that. That usually scares people away from calculus because it's the first chapter. And I have to like keep students in there, be like, the first test is the hardest one. The other ones are easy. You're gonna be okay. But you gotta go to a teacher that might drop that lowest test grade because it's probably gonna be that first one. And then they're like, oh my God, I don't think I could survive. And then they go to the next chapter, it's like, oh God, this is even worse. And then they go to the next chapter and like, there's a shortcut and I can eyeball the answers. Okay, that's cool. Great. Love it. I haven't done calculus in a few years. I'm kind of bored. All right, so let's move on. Does that sound nice, children? Oh, that's good. Okay. All right. So we're gonna do lines. Yeah. See, she got that one.
Perfect, yeah, all night, count sheep.
Yeah, I don't think I'd be counting sheep. Maybe, atoms and, my single strand of hair. I swear I can see them. 1, 2. Told my coworkers this morning, I'm tired, so tired every morning. Maybe I should just take cocaine. When you're a phlebotomist, they would very much frown upon that. It's frowned upon in any profession.
Unless you're like.
Huh?
Unless you're like.
I've known a lot of those, and actually, yeah, actually the ones that I knew were very clearly on heroin. So it was the other way. Maybe that made the burns a little easier. I don't know. People you meet while selling video games. Got some stories. All right. So, lines in the coordinate plane. So all linear equations can be shown as a graph of a line. So all of the straight lines that we've been doing, x is equal to 4, that sort of thing, we can draw them all as a line. So they're represented by a Cartesian plane. No, you're not going to have to memorize that word or how to spell it. It is literally your standard graph. You have an x-axis going horizontally, you got a y-axis going vertically. They meet at a point, you call that point the origin, and that's the point where they're at 0, right? Both axes are at 0 at that point. So you end up having different points on this graph. Well, rather cover that in the next slide. So graphing a point. You gotta be able to do a point before you can do a line. So graphing a point isn't bad. You're always given your point in something that kind of looks like interval notation. You have a set of parentheses, a number, comma, another number. Those are always in the form x, comma, y. It's giving you an x value and it's giving you a y value. So we have, in this case, 3, comma, 4. So in order to graph that, you would say, okay, well, if I have 3, 4, that means 3 in the direction of x. So x is going negative in the left, positive in the right. It's basically, hey, there's our number line, but now it's got height to it. So gonna go 3 in the X direction. So from 0, 1, 2, 3, cool, that's where we are in the X direction. And 4 in the Y direction. So again, positives up here, negatives down here. 1, 2, 3, 4, there we are right there. So you slap a dot on there and you put it in parentheses 3, 4. Now, you're not always gonna label your points, but when you're just starting off on graphing, I recommend it. The more complex your graphs get, you might just drop doing that. But at least for now, while you're just graphing lines, you're getting used to it, you're getting a feel for it, go ahead and label those. And the reason I say that is because sometimes people will read this backwards. They'll see 3, 4, and they'll go 3 in the Y and 4 in the X. So they would be over here. You can look back over your work and say, oh, I messed that up. It's a good way of checking it. So make sure you keep that label on there just to be safe. Just so you can figure out if you broke something later. Make this text box so big. Whatever. Okay. So this particular graph of a line is the equation 3x plus 2y is equal to 4. Did that mean anything to you right now? No, but that's what it looks like. So that's in standard form of a line, which is always in the form something x plus something y is equal to something. Ax plus by is equal to c. So the thing about standard form is you're never really going to use it. You will later use standard form, but you will be using it in a context where keeping in mind that it's standard form isn't going to matter at all. So for the most part, right now, we have standard form. I prefer a different form. We're going to see that in a few slides. And by a few, I mean potentially several. So the idea here is that that line is going infinitely in either direction, and every single point along that line makes that equation true. 3 times the x value plus 2 times the y value is always going to be 4 at any point along that line. So you end up having, if you have 3x plus 2y is equal to 4, you end up finding, to make a graph, you find little points like, okay, well, if this is going to cover everything, what is the graph? What is my point going to be at if I plugged in like a -1? If I looked at x is -1, where would my y value be? You figure it out and you put it on there. Okay, what if x was 2? And you figure it out, figure out where the y value is, and then you put it on there. And you get a couple of points, and you can say, okay, well, assuming these are correct, I can draw a line between them, and you can cover everything that way. So that's exactly what we're going to do. How to graph. Easiest way to start off is plotting some points. How do you plot the points? Well, we got to figure them out first. And I will tell you that if you keep going in math, if you go into some crazy engineering stuff and you start doing some really wacky math problems, and you have to graph something that's hideous, this weird curve, and you don't know exactly what it's going to look like, you will absolutely just be like, I'm going to plot some points. 100%, it is a forever fallback. It is a good method. There are better methods in different situations, but end of the day, this will get you to where you need to be. So basic equation, we're using y is equal to 2x plus 1. And we can find sets of points by plugging things into one variable and figuring out what the other one is. Usually we just plug things into x, but You absolutely could do both. It doesn't matter. In the form this is in, whatever I plug into X is immediately gonna spit out a Y. So it's gonna be a lot easier to just plug things in for X. In a normal class, the first lesson on doing these normally has a big pile of charts of, here's a bunch of X's, find the Y's. So of course, that's the way we're gonna start off. And after that, it just kind of says, all right, well, now that you get the idea, figure out your own points. Now, the nice thing, I always like to do something in the negatives, something at 0, and something in the positives, just because that gives me a nice kind of range. I can actually have a decent looking graph if I go with that. Sometimes I'll do 2, sometimes I'll do 1, sometimes I'll do 5. I don't know. It just depends on the situation. And it will come up as to what I would be looking for. So for every single one of these, we are going to take our equation and substitute those X values into our equation to find the Y values. I actually don't know why I have this slide. Totally could combine those, whatever. All right. So here's all the values, but we do have how to find it on the left. And it's basically like if you were gonna go check an answer. You would take your value and you would plug it back into your equation and work it out until, you know, you get something a little more concrete. So in the case of X being -2, you take that -2 and you're gonna swap it out for that X, because we're saying X is -2. By doing that, we're gonna figure out what the Y is when X is -2. So you plug that in, do the multiplication, 2 times a -2 is a -4, plus 1, you get a -3, throw it at your chart. The 0 is usually my favorite one to plug in. Because if I plugged in a 0 for this X, what's 2 times 0? Gone. So it's usually just this number right here. So you'd have 0 plus 1, 1. Okay, well, what if X was 2? If X was 2, we'd have 2 times 2, which is 4, plus 1, 5. Cool. So you have 3 points. You take those 3 points, and in the exact same way we did that earlier point, we plot them on a graph. -2, -3, that's -2 on the left. -3 down, draw your point, label it. 0, 1. 0 means you're not going left or right, you're just staying on the axis. 1, go up 1, draw your point, label it. 2, 5. 2 to the right, up 5, draw your point, label it. Now, if you've done things correctly, your 3 points should be along a straight line. So if that's the case, you just draw a line between them and you're good. We have our line, we're happy. Now, if you make a mistake, well, your line's going to be pointing a different direction, right? Cause some problems. But the reason that we do 3 points is just to make up for that. If you make a mistake, your 3 points will not line up unless you somehow made a really impressive way of making the same mistake 3 times in a row. But that third point is just for a check. If you are 100% confident, you can absolutely get away with doing 2 points and drawing a line between them. That's fine. It's not going to be the end of the world, but we always do a third one just for a check. If this thing had a curve in it, you might do 5 or 6. Wanna wait time?
Yep.
All right. Yeah. Yeah, it was nice to have slightly more people for a moment. All right. So we got 4 problems here. We're gonna graph a few of them. Are you excited to graph? Yeah. Yeah, you are. You might not know you are, but you are. You're really excited. Okay, so we have y is equal to 3x minus 2. So is the meme very accurate for everybody today? Like just kind of looking like that, kind of feeling like that. Yeah. Let's take that thing, make some graphiness to it, right? So in this case, I have no points, right? We're not given a chart of points, so we gotta kind of make up our own. And like I said, usually I'll just stick to some easy ones. In the case of most of my problems, you'll find me using -1, 0, and 1, just because those are really easy to plug in. Because I'm multiplying something by either 1 or 0, that's making my life really easy, right? And it's all about making your life easy at this point. I don't want to deal with making it hard. I could have plugged in a 50 and then had to graph all the way to 50. That sounds awful. I'm not going to do that. So we're going to start off with this -1. We have y is equal to 3 times -1 minus 2. So we just take that x value, plug it in for the x. I usually use a parentheses, so any symbols happening on there, if there's an exponent, if there's multiplication, which there is, I'm not going to screw it up. So I usually just swap it out with a parentheses. So this will give us -3 minus 2, which is a -5. All right. Slap it in there. And if it helps to keep things straight, you can always do, oh yeah, this is where I plugged in x is -1. That would differentiate when I plug in x is 0. I'd have y is equal to 3 times nothing minus 2. Well, 3 times nothing is nothing. So it's just -2. And then I got a 1. Y is equal to 3 times 1 minus 2. That's just 3 minus 2, 1. Now you probably thought my line graphs were lazy before. Wait till you see my plots here. So we got these 3 points to graph. Here's how I tend to do my graphs. My y-axis, I don't really care about the range between -5 and 1. So I'm just gonna make sure that like my axis is, I got a lot down here. My x, I'm just going from -1 to 1. I really don't need all that much room. That's my x, that's my y. Not too bad, yeah? So I'll do some little marks here. 2, 3, 4, 5. So obviously I don't make the prettiest graphs, but the main things to keep straight would be the distance between your points here, because the more wonky that gets, the more horrible your graph is going to be if you try to connect three dots. So our first point, we have -1, -5. Okay, so that's -1 in the x direction and -5 in the y direction. That'd be right there. We label it -1, -5. Our next one, we have 0, -2. That's nowhere going left or right. We're just staying on the axis. -2 right here. That's 0, -2. And then we have the point 1, 1. Well, an X is one, Y is one. That look like three dots are gonna be connected by a straight line? Yeah, right? That's all we do. Draw a line between them. Then we're happy. We have now graphed a line. Feel accomplished? 1 out of 5 is not bad. Also, having 5 people in the room at once in the last week of this class, that's unheard of. Usually you guys would have dropped off faster than that. So more power to you. I usually end up with 1 or 2 in the last week, so. It's kind of depressing, but I got used to it, about 2.5 years ago. Then I found out the morning class very often will not have nearly as many people in the first place. Apparently people have more free time in the evenings, and then as time goes on, people miss their free time in the evenings. Let's skip number 2 and go straight to 3. Number 3. We have 2x plus 4y equal to 8. Now, once I clean this up, I will show you that there is a shortcut available for how I'm going to clean this up a little bit. But if I have something like this, this is in standard form. So we could technically plug in anything for x or y, right? Technically, we could have done that over here, but it would have been really annoying. We'd have to add 2 and divide by 3 every single time, and that would have been frustrating. So I'm going to show you a nice way of dealing with these types of problems. The way I like to deal with these problems is I always like to solve them for y. I always solve for y. Because once I'm done with that, plugging in my points is significantly easier. And then we're going to learn another way of graphing later, and that's honestly, this is the way we're going to do that anyway. So we're going to be doing half of that method right now. So we're going to solve this thing to get the y along. How am I going to do that? Well, I'm just going to move away everything on this side that isn't y. I can't divide by 4 yet because of this 2x, so I'm going to subtract the 2x off. So we have 4y left over here, equal to minus 2x and a positive 8. So notice I didn't write 8 minus 2x, I put the x term first. And then since the 8 was already positive, I said it was negative 2x plus 8. There is a good reason for that, but we will see that in the next subject. This is going to make your life easier. It's just having the x value, that x term first. And then we divide by 4. Now when I divide by 4 to get the y alone, I have to divide everything by 4. That's all well and good for the 8, but we end up with fraction right here. We can break that down a little bit. We can say, okay, well, negative 2 over 4, that's the same as negative 1 over 2, right? We don't necessarily have to even have the x on the top. We can have it on the outside. You can pull that out. That's fine. I prefer it that way, honestly. And then 8 divided by 4 is 2. Okay, cool. Well, this, now that I have this, I can see everything I plug in for x, like I did up here. We had 3x minus 2. Everything I plugged in for x got multiplied by 3. Everything I plug into x here is going to multiply by 1/2. So if I plug in a 1, I'm going to get a fraction. I'm going to add that to this, and I'm going to get a fraction. Then I'm going to have to try to graph a fraction. Don't graph fractions. It's ugly, it's stupid, and you're usually going to make a mess out of it. So the reason that I do it this way is because when it comes time for me to pick what points I'm going to throw at it, I like to pick multiples of that denominator. We have negative 1/2 times x. Oh, well, How do I avoid fractions? Everything's getting multiplied by 1/2, so just make sure that it's gonna come out even. So, as long as we got an even number plugging in for x, we're good. So I might not do -1, 0, and 1, but I could totally get away with -2, 0, and 2. Works great, right? So, if x was -2, we would have y is equal to -1/2, -2, plus 2. That's kind of ugly, right? But it's not honestly too bad. Negative times a negative, that's going to give us a positive. 1/2 times 2, 1. So we know we have a positive 1 plus 2, we get a 3. Effort. How about the 0? I always pick the 0 because the 0 is the easiest one to plug in. -1/2 of nothing plus 2. Well, -1/2 of nothing is nothing plus 2, just 2. And then I could plug in that 2. We have y is equal to -1/2 of a 2 plus 2. So in this case, we have a negative times a positive. So we're going to have a negative. 1/2 of 2 is just 1. -1 plus 2, 1. Cool. Those points don't suck. If I had plugged in any odd number, these points would have been awful. And I would have had to do a lot more over here. So I'm pretty happy with that. So solve for y. Makes life easier. So we're going to take those points and we're going to graph them. Let's see, my x's go from -2 to 2. My y's go up to 3 and they don't have any negatives in them, so that'll work. -2, +2, that's my x, that's my y. 1, 2, 3. Perfect, good enough. Isn't it beautiful? That's how you half-ass a graph right there. Okay, so we take that. We got our points. We got -2, +3. So x is -2, -2 in the x direction, +3 in the y. Right there. Label it. Next one is 0, 2. 0 in the x, 2 in the y. Next one is 2, 1. 2 in the x, 1 in the y. 1. Yeah, those look like they're all in a straight line. So we draw one. That's kind of straightish. Good enough. Cool. How do you feel about graphing lines? Is it horrible? Is it reasonable? Do we need to do more on this specific method? What are you guys thinking about?
How much I suck at that.
Huh?
How much I suck.
Yeah, that's fair. What was yours?
My bad.
Your bed? Cool. I'm also thinking about your bed. Whoa, the window was open and I had to jump through it. Oh my God. My coworker walked up to me earlier today and she was like, "Is that your nipple through your lab coat? Can I see your nipple?" And she, like poked and she was like, "Ooh, it is." And I'm like, hey, get back here. You did mine. It's only fair I do yours. She disappeared. That's why Ben is referred to as an HR nightmare at some of his jobs. I actually was referred to by my boss at GameStop as an HR nightmare. And then I proved him wrong. No, I proved him right. I'm just kidding. My 2-week notice was sticky to the top of the GameStop subreddit for a while. Went public. They had to lock the internal message board and everything. Anytime the district manager wanted to post something, he'd have to unlock it, post, and then lock it again. And then other store managers started quitting and they were using old group texts. And some people were like, "Hey, I quit this place last year. Please don't text this." I'm like, "Sorry, that's all I got." Whole damn district quit. It was fun.
Yeah, you worked there for a minute, huh?
13 years.
Yeah, I
Yep,
remember coming in there, dude. I remember you.
yep. I was there. And if it burns down, I will throw a party. And if it doesn't burn down, that's how I'm going out.
I just wish I had my money in the GameStop stocks.
It's happening again, apparently as of, earlier today, actually. Yeah, right. They locked the markets all stopped trading that stock because it was too volatile. Because people started going crazy buying it again. So at some point in the next week, I'm gonna buy some. And I don't even care, I'm just gonna sell it like the next day. I don't even care. Just minor profit. Love it. Oh, okay. How checked out is everybody? Okay, I got 4 out of 5 people immediately being like, "Oh God." Shall we call it good? Are we okay with calling it good?
Some great.
Okay. We're gonna call it good for there. Because the next class is going to cover everything else relating to lines. All of it. That's where we're ending the class. And if we don't, then we're gonna start playing along with these things. Which looks horrifying, but it's actually really easy. I think I go through that whole lesson in like 5 minutes.
Well, great night, sir.
Okay, I'll miss you all. Part is all warm now.
I think it's starting to like it. Keep warming up.
Good time for it.
Get longer than.
That doesn't take anything serious.
All right, Ben. Take care. Have a good night.
I'll hopefully see all of you on Thursday,
Yeah.
or at least